All right, everybody. Today we're on to topic number 5, which is central tendency. Let's go ahead and hop over to our lecture slides here. All right, so central tendency, what is it? Well, we are still doing descriptive statistics. We just wrapped up with organizing, displaying, and describing data. This is another way in which we can describe data, and we are specifically describing data in terms of the center of a distribution. And what center means is up for discussion. All right, we're going to talk about a few different ways that we assess the center of a data set. So let's go ahead and talk about it. When we describe distributions, we want to know where the data is centered. What would we describe as a center or representative point in a given data set? We also want to know how spread out the data is, or the data are, in fact. How spread out is the data? That'll be on our next topic when we talk about variation or variance or variability. These are all ways in which we can describe data sets even further. So for now, we're talking about central tendency or measures of center. Central tendency means the middle of a group of scores. Measures of central tendency are meant to represent the data. They are meant to be representative of the data. So we're going to talk about 3 different types of central tendency here. We're going to talk about the mean, the median, and the mode. Perhaps terms that you've heard of before. So we're going to get a reminder on how to calculate these terms, but we're also going to think about what they are and what they do, right, and the limitations of each. So let's go ahead and start with the mean first. The mean is perhaps the most used measure of central tendency. And we also have here our first formula, first official formula for this class anyway. So we have the mean. We have 2 symbols here for the mean. We have what we call x bar, so x with a bar over it. X bar is the mean of a sample. And then what we also have here is the Greek letter mu. Greek letter mu. That would be the mean for a population. And that's going to come into play a little bit later when we do what we call hypothesis testing. So it's something to keep in mind. So what is an average? It's the sum of all of the scores divided by the number of scores. Please pardon the dog jingling if you can hear that. A sum of all scores divided by the number of scores. So we have n here with us again. And we have a few other symbols. So the next slide here is to pick apart all of our different symbols here. And then let me move my, move my little head out of the way here. For you to take a look. So we have the symbols for the mean. And then we have sigma. We introduced sigma back when we were working with frequency tables. But a capital sigma, capital Greek letter sigma, is the symbol for sum of. So when we see this, what it means is we want to sum up everything following the sigma. So in this case, it's saying to add up all of the numbers of whatever follows. And in this case, whatever follows is variable x, all right, or whatever variable of interest we have. So the x stands for all of the scores in the distribution on our variable x. And then we'll have n in there as well. In this case, we'll be using a lowercase n because x bar is the symbol for a sample. All right. So let's go ahead and I'm going to pull up the whiteboard for us in just a moment here. And we're going to work through calculating our first mean or our first average. All right, so I'll go ahead and show you here on the next slide. We have a little bit of data that we want to consider. All right, here's some data that we want to consider. All right, so this is illustrating how we go through the basic procedure here, the basic calculation. If we have a set of x values, and let's say that these x values are number of dreams, okay? Number of dreams that an individual might have. Maybe we want to get an average number of dreams for each person, okay? So we have a number of dreams here. let's go ahead and hop over to the whiteboard, and I'm going to write down these values. All right, let's get these down here. So we have a 7, an 8, an 8, a 7, a 3, a 1, a 6, a 9, a 3, and an 8. Let's see, is that all of them here? This is an n of 10. All right, so I'll go ahead and say n is equal to 10, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 scores here, right? 10 reports of scores. Okay, so let's take a look at that formula that we just learned. So to calculate a mean, what we need to do is sum up all of our variable x and put it over n. So in this case, what would we do? Well, we would take each of these values, add them all together, and then divide by the total number of scores we have. So again, you might be thinking, or maybe not, right? Depends on our experience with statistics. You might be thinking, hey, I calculate averages, right? I know what's going on, which is why we don't spend a whole lot of time here on calculating averages, and rather we worry about the conceptual bits of means and averages. So here we have it. This is what the equation would look like. You would go ahead and sum up all the x values. We'll give you something like 60. If we put it over 10, we end up with a mean that is equal to 6. All right, so that's our basic calculation here. Let's go ahead and pop back over to the slides. That's what's being represented here. We have all of our values, we sum them, we divide by our n, which is 10. All right. So what's the point of getting a value like this, all right? Why do we bother with calculating a mean? Well, a mean is somewhat of a balancing point. Remember, it's meant to be a measure of central tendency or center for the distribution of scores. So it's supposed to speak for the data in a certain way. So here we have something that emulates sort of a histogram, right? Or something expressing the frequency of each of these values in our data set. And we can see how the mean sits at a point that is kind of balancing the distribution, right? Sort of balancing the distribution here. The mean can balance the distribution in a number of ways. Here are a few more examples here. So looking at the kind of the balancing point for all of these distributions, we can see that they are in different places. In fact, for 3 of these, we have means of the same value, but with very different spreads of data. So means are limited in their understanding at least a bit, right? Because one number can't fully describe an entire data set, but it can describe something about that data set, right? And it can explain where center is to some degree. All right, so we're going to talk about another type of central tendency now. We're going to talk about something called the mode. The mode is the most common single value in a distribution. This can be thought of as the highest peak on a histogram, right, or the most frequently occurring value. And the mode is special in that it can be used for qualitative and quantitative data. So let's think about what that means for a second. If I wanted to, say, collect data from all of you on your eye color, all right, and I had a long list of eye colors, I couldn't add up and get an average of eye color, right? I couldn't average brown plus blue plus green plus brown plus blue plus brown, right? That's nonsense, right? Because that's qualitative data, it's not quantitative. However, we could get the mode. We could determine which of those categories is the most frequently occurring. But we can also do this for quantitative data. So let's go ahead and take a look back at our data set here, and let's see if we can figure the mode. All right, which of these values is occurring the most? Well, we can do a quick scan here, right? And if we take a look, we can determine that we have 1, 2, 3 8s, and no other value repeats as many times as 8. So our x bar is equal to 6, our mean is equal to 6, and our mode is equal to 8. All right, so the mode is another measure of central tendency, right? It's meant to be representing the center in some way. But you can see here we have two different values now that can represent center depending on how we want to describe the center. All right, so let's go ahead and hop back over to our slides here. So that's the mode, the most frequently occurring. We don't have a calculation for the mode. It's something that we will just manually need to find in our data. But thankfully, we have software that can do this for us, right? It's very easy to find, say, a mode using the descriptive statistics feature of SPSS. So here we have a depiction here of our most frequently occurring value and the highest point or the highest peak on our data visualization here. It's the most frequently occurring. All right, so we have one more type of central tendency to address, which is going to be the median. All right, let's move my head yet again. All right, the median. All right, so the median is a little different. The median is what we might consider to be the literal center of a data set, all right? So we have a little bit of a calculation here to help us find the position of the median. So we will go ahead and demonstrate this momentarily. So if you line up all of your scores from lowest to highest, the middle score is the median. And by middle, we mean the actual middle of the scores. So we take n plus 1, and then we divide by 2. N plus 1 divided by 2 will tell you what position to look for in the data set. So again, we'll hop over to the whiteboard and take a look at this in a minute. But we don't always have odd numbered data sets where we have a specific middle score. We can technically have two scores that lie in the middle, and then we take an average of those two scores. It's kind of a central tendency of two central tendencies. It's a little bit of a little meta, isn't it? So we'll go ahead and work through a couple examples where we give this a shot. So let's go ahead and hop over to the whiteboard, and let's consider what the median might be here. Okay, so for the median, we want to take n plus 1 divided by 2. N plus 1 divided by 2. And before I get going with this, let me just say, this is how I like to write this out for myself. I like to say, okay, I'm going to get the median position. So I write in kind of subscript here that I'm going to find the median position. So I'm going to take n plus 1 divided by 2. Well, in this case, our n is equal to 10. So we're taking 10 plus 1 all over 2. That equals 11 over 2, which gives us 5.5. Okay, this is the position in the data set that we need to find in order to determine the median. But something else we need to be aware of is that we need to look at the data in an ordered form. So I need to take this data here and put it in order. And what do I mean by order? I mean by going from the least to the greatest values in the set. So we have 1, 1. We can kind of treat this how we did with our frequency tables, right? We'd say, okay, there's 1, 1. Are there any 2s? No. Are there 3s? There sure are. We have 2 3s. All right, so we got our 1, our 3, our 3. Are there any 4s? No. Are there any 5s? No, but there is a 6. All right, there's 1 6. There's 2 7s. All right, so we have 6. We have 7. We have 7. We have 8. We have a couple of 8s, right? We have 3 8s, in fact. That's the mode. All right, so 1, 2, 3. And then 9s. We have 1, 9. All right, so now the data is in order, and we need to find the position of the median. So we have a position of 5.5. So let me go ahead and label these. So we have position 1, we have position 2, we have position 3, 4, 5, 6, and so on. But we're looking for position 5.5. So we're looking kind of right here, right in between these two scores. This is the position of the median. So remember, this is where we have central tendency within central tendency. In order to figure out the median, we now need to get an average, right, or a mean of these two scores. And how do we get a mean of two scores? Well, we add them together and we divide by 2, all right? This gives us 14 divided by 2, which gives us 7, all right? So our median in this particular data set is equal to 7, all right? Median equal to 7. Let's go ahead and get this circled here. Okay, so we have 3 measures of central tendency for this data set. We have the mean, the median, and the mode, and they are all different. They're all expressing the center of this data set in a different way. All right, so researchers have to determine which of these is the most adequate for their data. If you've ever taken a look at a scientific paper or a research paper, you'll notice that the mean is often the most reported. That's because the mean includes, right, if we take a look at the formula, the mean includes every score. Every score is part of the calculation of the mean. The same can't be said of the mode and the median, right? We didn't calculate anything in the data to find the median, nor for the mode, right? We're simply looking in the data. So that's the major distinction here, that the mean includes every value for our group here. All right. Let's see what we got here. I realize that this is a little bit cut off. Let me see if I can fix this for us. There we go. All right, oh, there we go. There's the bottom of our whiteboard there. Sorry about that. But here we are, all right, with our 3 different measures of central tendency. All right, and let's hop back over to the slides. We have a few more things to discuss here. So here we have the median. Here is in writing how we just acquired the median. If our n is equal to 10, if we order the values, find the position we need. If we have 2 values in that position, we need to grab a mean for it. If not, that middle position just is the median, and we will have an example of that to come here. All right, so the next slide here is just a bit of a source table for central tendency measures. So we have formulas or calculations for the mean and the median, no such calculation for the mode. Then the description of each of these is as follows. So the mean is meant to be a balancing point, right, including every possible score in your set. The median is a middle value, a more literal middle value in the ordered data set. Then the mode is just the most frequent. So we're going to go ahead and give another example here with a small data set. It's going to help us understand the relationship between the mean, the median, and the mode. They are all related, and they all have their time to shine, so to speak. There are the best times to use each of these values. For example, the mode is best used when we have qualitative data. But let's take a look at when we might want to consider, say, using the median instead of the mean. Let's take a look at our next slide here. So we're talking the relationship between the mean and the median here more specifically. The median can be better than the mean at a representative value for a group of scores if we have, say, a skewed data set. Remember the word skew? Or if we have something called an outlier or an extreme score. So we're going to consider a couple scores here. We have some reaction times. So remember, shorter reaction times are better. Lower values for reaction times are better. It means you reacted more quickly to something. This is a very commonly used measure in cognitive psychology. Right? How quickly can you detect a stimuli? How quickly can you answer a question? So we have a list of reaction times here, and we're going to find the mean and the median for this data set here. We're going to see how the median de-emphasizes more extreme scores, or scores that we might call outliers. So let's go ahead and hop back to the whiteboard and let's get us a new slide. Apologies again for getting us a little cut off here. I will make sure that does not happen to us again. All right, so let's go ahead and get our data here. The data that was on the slides, these are reaction times. So we have the value 0.74. We have the value 0.86. We have 2.32, we have 0.79, and we have 0.81. We have an n equal to 5 here. Okay, so here are our scores. Let's go ahead and grab a mean for these scores, all right? So the mean is equal to, all right, or x bar is equal to the sum of all of these scores over n. All right, so if we go ahead and carry on here, we would take 0.74 plus 0.86 plus 2.32 plus 0.79 plus 0.81. And we would put that all over 5, right? Because we have 1, 2, 3, 4, 5 scores. We end up with something like 5.52 over 5. All right, and just a reminder, since this is an online class and these are pre-recorded, I hope you do this along with me and take the time to say, pause the video, work the math out yourself, and then continue watching to check to see if you got it right. It's very easy to passively follow along with this stuff, but practicing is how we get better at statistics. So I really do advise that you give this stuff a shot, even if it does seem very simple, all right? Make sure that you can get the same thing on your respective calculator. And here we end up with a mean of 1.104, all right, 1.104. So there's our mean. Okay, here's our mean. That's great. Let's try for our mode. Okay, is there a mode here? There's not, right? There's no mode here. We're just going to put NA. And that's okay, right? The mode by definition is the most frequently occurring value. If no value occurs more than once, then we don't have a mode. You could also say that all of these are the mode, right? But it's really not applicable, right? Not a useful statistic in this case. So let's also try for the median here. So remember, we have a little trick calculation to get the position of the median, which is n plus 1 over 2. All right, we have 5 plus 1 over 2 gives us 6 over 2. Means we're looking in the third position. All right, I like to remind myself that it's the third position, because position means that if we put these in order, which I'll go ahead and do, if we put these in order, let me change color too so we can kind of highlight these better. We have different positions in the data set. All right, this is the first one, second, third, fourth, and fifth. All right, so the median is in the third position. So we go 1, 2, 3, and we land here. All right, so our median is equal to 0.81. 0.81. All right, so we might ask ourselves, right, how did I get here? No, not a talking heads joke. Instead, we might ask ourselves, right, which of these values is more representative of the data set? All right, which one of these is truly more representative? The mean, all right, this score here or this score here? Well, this is a pretty small data set, right? So we would not be making such a bold conclusion on a small data set. But something we might think is all of these scores, okay, are pretty close to each other, all right? These are all within about a 0.12 range of each other. And then we have one score that's very different from the others. We might call this score an outlier. We might say that based on the data in this data set that this 1.104 value isn't exactly representative of the data set. In fact, we don't have very much data that looks like this in our data set. But what we do have is more data that is closer to this value, right? So again, this is where statistics isn't entirely black and white, right? Sometimes we need to make decisions about what is more representative in terms of describing our data, all right? So just an example for us here. And before we go today, I'll do one more example of getting the mean, median, and mode from another data set. So let's go ahead and get a fresh slide here, and let's give this a go. All right, I'm just going to put some data down, and we'll go ahead and calculate our central tendency values for these. So we have a 3, a 7, an 8, a 10, 12, and a 13, okay? And then our n is equal to 6. All right, so let's go ahead and start with our mean. Our mean is equal to the sum of x all over n. So what would we do? We would add all of these together. All right, we would add all the scores together and we would divide by the total number of scores. This gives us something like 53 over 6, which gives us a mean of 8.83. All right, 8.83. That's our mean. All right, there's our mean. Let's go ahead and try for the mode here. Mode. Would you look at that again? We don't have any repeating values here, so the mode is not applicable. All right, mode is not applicable. And then if we try for the median is equal to, or the position of the median, we should say, is equal to n plus 1 all over 2. We have an n of 6 plus 1 all over 2, 7 over 2. This gives us the 3.5 position. So let's actually just hop back up to the top here. These are already in numerical order in this case. So if we look for position, we have the first, second, third, fourth. We'll label the rest here. But we're looking for position 3.5, all right, somewhere between here. So these are the two values that we need to crunch and find the center of these two in order to find our median. So we would grab an average, okay, an average of just the two scores. So we're averaging the two scores, we're dividing by the number of scores. We got 18 over 2, which gives us a median of 9, okay? So we have an x-bar of 8.83, and we have a median of 9, right? So let's see. I have a few more examples of these, and we have a homework on this. So for this lecture, I'll go ahead and leave us here. Take a look at the homework assignment that we have on the mean, median, and mode. And then, of course, with this class, we do have live sessions. So if you have any questions on these, just be sure to bring them to our next live session. And I will see you over on the next one.